Hello, welcome to another iotkg video. In this video, we'll be setting up another Espruino device called the Pixl.js. This works similarly to the puck, but has a different footprint which is the same as another popular microcontroller called the Arduino Uno. This means that it is compatible with many add-ons made for the Arduino, and it is very easy to plug new sensors into the device. It is powered using either a coin battery or a micro USB cable, and also comes with an inbuilt LCD screen. For this video, we'll be looking into connecting an external moisture sensor. However, this can be any sensor of your choosing as long as it's compatible with the Arduino Uno. For example, this pH sensor, which will be explored in another video. There are a variety of sensors and kits that you can choose from, and we've linked a couple recommended ones in the description below. Some kits conveniently come with a shield, which is a board that plugs on top of your microcontroller that makes plug and play with multiple sensors very easy. If you don't have a kit, you could also connect a sensor using these jumper leads as well. It is important to note that some sensors are more difficult to code than others, but information is usually available online. You may want to watch the whole video first before trying out the steps, so that it'll be easier to follow. All code snippets discussed in this video are also available in the description box below. First, we need to flash the iotkg firmware onto the Pixl. Power the Pixl while holding down button 1, which is labeled on the bottom of the board. On the LCD screen, you should see a bar filling up, above which says Release button 1 for DFU. You need to release the button while the bar is still filling up. Do not wait until the bar is filled up completely, otherwise you'll have to try again. The screen should show that it's ready to update. The rest of the steps are very similar to the process for setting up the puck. On your mobile device, download the Pixl firmware from the iotkg website, and then connect to the DFU tag device on the NRF Connect or NRF Toolbox apps. Then upload the zip file you just downloaded from the iotkg website to the Pixl. If you want more detail for these steps, skip to this part of the Setting Up Espruino device video. Now, we can plug in our sensors into the Pixl. In this case, we're using a moisture sensor. It is important to note that different sensors may have different requirements, so you may have to read any instructions which come with the sensor, or look online to find out how to use a sensor that you've chosen. The moisture sensor shown in this video has 3 pins. Plus, which needs to be plugged into the voltage source, minus, which needs to be plugged into ground, or GND, and A, which is our signal pin, where the data is transferred through. We need to connect the plus on the sensor to the 3.3 volt pin on the Pixl, and minus to the GND pin on the Pixl. The labels on the Pixl for these pins are offset, so be careful when plugging into the pins. The moisture sensor only works if plugged into an analog port, which is labeled with the letter A, so we can plug it into one of those. Take note which pin you plugged it into. In this case, the A0 pin. Next is writing the code for the Pixl. On the Espruino web IDE, upload the following code to the Pixl. Replace pin with the pin that you plugged the sensor into before, which would be A0 for this case. In this block of code, we are creating a function called getMoisture, within which we will write instructions to read data from the moisture sensor. Functions allow us to keep our code modular and avoids us having to repeat writing the same lines of code again. The second line reads the input value coming in from the sensor, and then stores it in a variable called value. You can think of a variable as a bucket that stores a value in it. The last line prints it to the console on the left so that we can see it. The values coming back from this sensor might need mathematical adjustments to turn them into numbers, which makes more sense to us. For example, the moisture sensor returns very small decimal values under 1, so maybe you would want to multiply it by 100 to make it a percentage. When you're happy with the value that you get from this, we can now add some extra lines of code to send our moisture sensor data values to the iotkg app. We do not need to print the statement in our code anymore, and so this can be removed. The final code should look as follows. Make sure to change the name to whatever type of sensor you have, which is moisture in this case, and also make sure to type in the name of the function that you made above into the getValue field. You can change how often the data is collected in the secondInterval field. 3600 seconds is 1 hour. Watch the video about adding the battery sensor for more detail on this. If using a battery-powered Pixl, turn off the LCD screen to save power. Your Pixl can still work even when the screen is off. This is achieved using the following command, which you can place at the top of your code. Finally, we can test out our whole setup. Disconnect from the web IDE, reset Bluetooth on your mobile device. This may have to be a hard reset in some rare cases. the Get device on the iotkg app, and then connect to the Pixl on the iotkg scanner. You should see your new sensor pop up. If you have any problems with the Pixl, do a quick reset by switching the power on and off. If that doesn't work, then do a hard reset by turning the power off and then turning it on while holding down button 1 for 10 seconds, until you get this on the screen. You can release the button after that. This will remove all saved code on the Pixl. Thanks for watching.